Imagine I hand you a solid gold ball. I cut it into a few pieces and give you back two identical gold balls, same size, same weight. I did not add a single atom. According to mathematics, I just did the impossible. And here is the part that should disturb you. This is not a trick. It is not an approximation. It is a formally proven mathematical theorem. This theorem is the reason mathematicians and physicists stopped eating lunch together. Now, before you say that violates conservation of mass, you are right. It violates physics completely. But mathematics does not live in the physical world. And in the mathematical world, this is not just possible. It is proven. So how? The pieces are not normal pieces. Imagine tearing a photograph into pieces. No matter how cleverly you rearrange them, you will never get two identical photographs. That is how your intuition works. Banach Tarski says infinity plays by different rules. When this theorem cuts the ball, it does not cut it the way a knife cuts an apple. Each piece is scattered across the ball in infinitely many tiny locations. Imagine dust sprinkled throughout the entire universe. Now imagine every grain of that dust belongs to the same single piece. They are called non-measurable sets. Wait, if the pieces have no volume, how do they create two complete balls? Here is the answer. These sets do not have zero volume. They have no measurable volume at all. Pause on that. Not zero. Undefined. Your intuition says every object must have a size. Non-measurable sets were specifically constructed to break that assumption. Because they have no defined volume, the normal rules of geometry, the ones that say you cannot duplicate matter, simply do not apply to them. There is nothing to conserve. The rules never had jurisdiction here. And this is only possible because of one tiny assumption sitting quietly inside standard mathematics. It sounds completely harmless. In fact, most people would call it obvious. The Axiom of Choice states that given any collection of non-empty sets, even infinitely many, you can always pick one element from each. But this single obvious-sounding assumption is responsible for one of the strangest theorems ever proven. Remove it, and non-measurable sets cannot exist. Remove it, and Banach Tarski disappears entirely. Mathematics gives you a choice. Accept the axiom of choice and live in a universe where gold balls can be doubled. Reject it and lose theorems that half of modern mathematics depends on. Most mathematicians keep it, and try not to think too hard about the gold ball. Now, can you actually do this in reality? No. Physical objects are made of atoms, finitely many, discrete. Non-measurable sets require infinite precision at infinite locations, impossible in physical matter. The Banach-Tarski paradox lives entirely in the mathematical universe, where points are infinitely small and infinity is not a direction but an actual completed object. But it still mattered enormously. The paradox forced mathematicians to completely rebuild measure theory, the branch of mathematics that defines what length, area, and volume actually mean. Today, that rebuilt measure theory runs underneath probability theory, quantum mechanics, MRI imaging, and financial risk models. Every time a doctor reads your brain scan, every time a bank calculates whether your loan is safe, measure theory, born from the wreckage of an impossible theorem, is doing the work. One ball became two. The universe answered no. But mathematics never questioned.